name is Marcelo Borges dos Santos, and I will show you the work that we made here in Curitiba. My work is called the application of the Galerti method in a stochastic bending problem, supported by a Pasternak Time Foundation. My colleagues' work is Cláudio Ávila, Felipe de Acirino, Luiz Mauro Moura, and Ricardo Kikuchi. As I mentioned, the work that we will show here is application of the method Galerti in a stochastic bending problem supported by a Pasternak Foundation. My name is Marcelo Borges dos Santos. I am from Curitiba. My colleagues were Cláudio Roberto Ávila, Felipe de Acirino, Luiz Mauro Moura, and Ricardo Kikuchi. The introduction. The present work aim is to present the displacement circuit by a beam supported by a Pasternak type foundation. The physical parameters that characterize both the beams and the foundation have an inherent uncertainty in a measurement process in a tight decimal place. To characterize the measurement uncertainty, it was proposed to use the Monte Carlo simulation. The beam has support at both ends and is described by an Euler model. To solve the different equation, the numerical method of the Galerti was used. Another foundation objective in this work is the influence of the uncertainty of the physical parameter of the beam for each different operation to which this parameter is associated on the propagation of the uncertainty of displacement suffered by the beam. Simple model as shown in the picture. We have a beam. You have the load over the beam, distributed uniformity from the beginning to the end. The quantity that this load is 1 kilopascal per meter. Mean values of the physical property and the corresponding standard deviation is shown in this below. We have, for example, the mean of the stiffness of the beam is 100 in the Pasternak Foundation 1000, in the Winkler Foundation 1000. The equation that describes the problem in high and different format have is shown in this equation. But we have to transform this form of equation to another equation with a lower different format. Transform the problem into an abstract variation problem, reducing the order of the differentiation of the set of the equation that form the solution of the problem. So when we transform in higher order to a lower order, we need to just reducing, we make the set of the equation that can be solve this problem more flexible. The stochastic variable which made up this sample space from a uniform time probability distribution function. The measurement of the probability associated with the entire set of the sample is numerical equal to 1. Galerti method was used in this problem consists to determine the coefficients of the beam displacement equation. The method uses an invertible operator on the stiffness matrix to determine the coefficients. This method is the computationally prohibited method because it is a recursive problem. As a criterion of the displacement amount simulation number, a minimum number was proposed. From each, the displacement average at the center point does not vary substantially with the number of the displacement samples. When the circuit rests on only the stiffness coefficients of the beam, the displacement sample has the format of the following graph. As you can see here, this is the all displacement that the computer produces using a simulation of the Monte Carlo. When the certainty falls in the term of the order of the first degree derivative, the propagation of the uncertainty is less pronounced. As is shown here, there is no much a variation in the mean value. Uncertainty about the foundation parameter described as Pasternak. When the uncertainty falls as the parameter associated with the zero-order differential Pasternak, the Pasternak foundation, in the equation that describes the problem, the uncertainty is practically imperceptible. All equations or displacement falls in this thin line. Final considerations. The greater order of the differential that the physical parameter is associated with, the greater is the propagation of the displacement uncertainty suffered by the beam. The uncertainty propagation function for all cases discussed in this problem has the following format. We use Monte Carlo simulation for parameter association. The lower order operation is practically unfeasible. I'd like to thank all observers, and any question, feel free to ask and send an email to us. The email is present in the paper.